Hello everyone, welcome to Pre-Algebra, Module 10. This is going to be a lecture on the last two sections that I want to talk about. One of them is on this idea of similar triangles, and then the last topic will be on the Pythagorean theorem. So let me start by defining what similar triangles are. We talked a little about this in one of the examples way back, but we'll talk about it in more detail now. So similar triangles are triangles that have the same shape but not necessarily the same size. So are triangles that have the same shape but not necessarily the same size. Okay, so I'm going to draw a couple of triangles here. Let me call this triangle ABC. So I'm going to label the vertices here. So this is, let's say this is A, this is B, this is C. And then let's say I have another triangle that has the same shape but different sizes. So let's say it looks like this. It's hard to draw this exact, but assume this has the same shape. It's just magnified, right? It's blown up a little bit. And I'll call this triangle DEF. Okay, so if I label this angle, this is basically angle A, and I'm going to put one little tick mark here to represent that in this triangle, this angle D is the same, has the same exact measure, right? It'd be the same measure in terms of degrees. And then angle B, I'll put two tick marks. That's the same as angle E, and then angle C, I'll put 3 is the same as angle F. So the corresponding angles are equal. So the corresponding, I'll write this clearly. In other words, angle A, I can represent angle like this. This means angle A is equal to, again, angle D. And we can tell that by this single tick mark, single tick mark. Angle B is equal to angle E. And finally, angle C has the same measure as angle F. Make sure you can see the whole thing there. What does that mean? Well, if the corresponding angles are equal, that means the triangles have the same shape. Okay, so this means the triangles have the same shape. In other words, they're similar. Okay, now the lengths of the sides, usually what we do is the side that's opposite of the angle, I use a lowercase letter. So since this is opposite angle A, I'm going to call that little a. That's the length of that side. Then this would be side B. This would be side C. Over here, this would be side D. This would be side E. This would be side F. Okay, what's important about the sides? Well, this is actually really important. Here's where it turns out the lengths of the corresponding sides are proportional. And this is what we're going to use quite often. So let me write that down here. So the lengths of the corresponding sides are proportional. So what does that mean? It means if I set up these ratios, right? If I look at, let's say I start with side A, well, what side corresponds to side A in the other triangle? Well, if I go to the similar triangle over here, it must be side D, right? That matches with A. It's corresponding. So if I write that ratio of the length of A over the length of D, that's got to equal, then I come back to this triangle, say B, what side is corresponding? That's the E here, right? So it equals B over E. And that ratio is equal to, again, if I come back here, this is going to be C, that corresponds to F. So it's equal to C over F. Right? Remember, when proportional means that two ratios are equal to one another. Okay, so we can use this, if we know two triangles are similar, we can use this to determine the length of unknown sides. So let's do an example here. Let's say I have this triangle, and I'll call it LOM. So LOM. And let's say these lengths are 8 feet, 6 feet, and 10 feet. Then I have another triangle. Let me call it RST. And let's say this is 15 feet. This is 9 feet. And let's say this length is unknown. So you can think of that as length RS, right? So I'll just call it Y for now. Okay, first of all, let's say we're told that these two triangles are similar. Now, the way that you can denote that is I could call this, so this is triangle LOM. So I'm just listing these vertices, right? These angles here, LOM. Then I'll just do it in the same order, RST. And to denote that they're similar, I use this like kind of squiggly line here. And then this would be triangle RST. So they're not really equal. This just means that they're similar. So same shape, different sizes. Okay, what it does mean though is that these angles, right? If you were to look at these angles, this angle would equal this angle M would equal angle T, and then angle O would equal angle S. Right? If they have the same angles, then they're similar triangles. Okay, but since they're similar, we know the lengths of the corresponding sides are proportional. So I can set up a proportion problem here, right, to solve for Y. If I start with Y, I'm going to form a first ratio, right? Y over its corresponding side. Well, what is its corresponding side in this first triangle? It must be the 8 here, right? So I have Y over 8 is equal to, and now actually I have choice here. I can either do 15 over 10 or 9 over 6 for my second ratio. So let me just do 15 over 10. So 15 over what's the corresponding side? The 10 here. Either one will give you the same answer. You could also have done 9 over 6. Okay, so now that I have this proportion, I can solve it. So remember back in chapter 5 where we solved proportions, you could simplify 15/10, right? I could write this as, this is what, 5 goes into 15 3 times, 5 goes into 10 twice, so that's the same thing as 3 halves. And then to solve this, I do cross multiplication, right? Upper left times bottom right, so that's going to be 2y equals bottom left times upper right. 8 times 3 is 24. And then finally, if I divide by 2, it looks like y is equal to 12, and it has units of feet. So that would be the answer. So y is equal to 12 feet. So this length right here Must have been 12 feet. Okay, here's another example. Let's say I'm given this triangle. And then a similar triangle here. I'm going to call this FEG. And then this one CBD. Okay, let's say this length is 7 centimeters. This length is 8 centimeters. This is X. Let's say BC is 2 centimeters. This is, say, 4 centimeters BD. And then this is Y. And let's say we're told that triangle F, you could either call it FGE or FEG. I'll just say FEG, doesn't matter what order, is similar to triangle, then I have to match right, CBD. Okay, and then the goal here is to find X and Y. So we can form a proportion, right? We can set two ratios equal. So let's start with X. If I start with X, I can form the first ratio by putting X over what? Over what is its corresponding side? Well, that's the 2 here, right? So I have X over 2 is equal to, and then I come back to this triangle. I guess I have to use this side, right? The 8 over what? The corresponding side is a 4. So it must be 8 over 4. Then actually, let me set up the equation for the Y now too. So the Y, I start with the Y in this triangle. It's Y over what is its corresponding side? 7. So this will be Y over 7 is equal to, then I have to come back to this triangle, 4 over 8. Okay, now I can solve these proportions. So here, actually you could simplify first, right? 8 over 4 is 2 over 1. You don't have to do that. You could just cross multiply and simplify later, but it's easier if you simplify first. Now I cross multiply, so X times 1 is X. And then bottom left times upper right, 2 times 2 is 4. And the X is isolated, right? So that's it. So X is equal to 4. So that's done. And really it has units, right, of centimeters. So that's 4 centimeters. Then I go back to this one. Let's see, I can simplify this. I don't have to, but I'm going to write it as 1/2 just to keep my numbers smaller. And then I cross multiply, so Y times 2 is 2Y. And then 7 times 1 is 7. And then finally, if I divide by 2, then I have Y is equal to 7/2 centimeters. Or if you want it as a decimal, right, you could divide it out and you'll find that Y is equal to 3.5 centimeters, right? 7/2 is 3.5. Either or, doesn't matter. Depends on what, it really depends on what my open math is asking for. Sometimes it wants a fraction, sometimes it'll ask you to leave it as a decimal. Okay, so if the triangles are similar, then the lengths of the corresponding sides are proportional. All right, let's do a couple of problems from my open math on similar triangles. Okay, so let's do this one example from the My Open Math homework. So I'm giving these two triangles. We're told that they're similar triangles, right? So we know that these angles would be equal. That angle would equal this angle would equal this angle, and then this angle would equal this angle. So they're similar triangles. We also know, since they're similar triangles, that the lengths of the corresponding sides are proportional. And the goal here is to figure out X and Y, those two lengths in meters. Okay, so let's see if we can set up our proportion problem. Actually, it's going to be two proportion problems, one for X and one for Y. So if I start with X, I want to form a ratio X with its corresponding side in the other triangle, well, that must be the 7.5, right? So I can write this as x over 7.5 equals, now I have to go back to this triangle with the x in it, and here's a known side, 6.3, over its corresponding side, which is 4.5. So this would be 6.3 over 4.5. And then for the other, for y, again, I start at this triangle, y, form a ratio over its corresponding side, which is 10. So I have y over 10 is equal to, come back to this triangle, and I'm using the same ratio, right? 6.3 over 4.5. Okay, so now I just need to solve these, and again, I'm going to use cross multiplication. So let's solve these. Let me write down this problem again. So I have x over 7.5 is equal to 6.3 over 4.5, and then this one's going to be y over 10 is equal to 6.3 over 4.5. Okay, so cross multiply, right? So upper left times bottom right. Well, that's going to be 4.5 times x, right? Or I can write it as 4.5x equals bottom left times upper right. Well, that's 7.5 times 6.3. You need to do that work somewhere. Let me just do it right here. Again, if you wanted to check this with a calculator, I'm fine with that. This is what, 3.5, 3 times 5 is 15, so 1. 3 times 7 is 21, plus 1 is 22, right? 0. 6 times 5 is 30, so 0 carry the 3. 6 times 7 is 42, plus 3 is 45. So this is 5, 2, 7, 4. So it looks like it's 42.25. No, sorry, 47.25. Okay, then what? Well, now I need to get the x by itself. I need to isolate the x. So I need to divide both sides by 4.5. So 4.5's cancel. I have x equals, it's isolated, but now I need to do that work out somewhere. Let me just do it down here. Divided by 4.5, so I need to move this one place, move this one place. Okay, hopefully this goes in evenly. 45 into 47 is once. Then I subtract, right? This is 2, bring down the next digit, which is a 2. 45 into 22 is 0 times, right? So I need to put a 0 there. 0 times 45 is 0. Subtract, bring down the next digit. And then, yeah, it looks like 45 into 225 is 5 times. So this would be 2, 4 times 5 is 20, yep, 22. Good. So it goes in exactly evenly here. So we know that x is 10.5, and then what were the units? Meters, right? So 10.5 meters. So that's the value for x. That would be the length of side x. So this right here is 10.5 meters. Okay, now let's do y. So same thing, I'm just going to solve it by cross multiplication. So I have upper left times bottom right, y times 4.5 is 4.5y. And then bottom left times upper right, 10 times 6.3. Actually, that's easy, right? Because I'm multiplying by 10, it's just going to move that decimal point one place to the right. So this is just simply equal to 63. And then to solve for y, I need to divide, again, both sides by 4.5. So this cancels. So I have y equals. Let me do the work here. Looks like I'm going to need to move this one place. So I need to put a 0 there. My answer will pop up there. 45 into 63 goes once. This is 45. Let's see, subtract, so 13 minus 5 is 8, and then I borrowed 1 here, right? So I have 5 minus 1 is 4, bring down the next digit, which is a 0, and then 45 into 180 goes in exactly 4 times. So this is 18, right? So y, I guess, is going to be 14 meters. And that's my answer. So in this picture here, the y is going to equal 14 meters. Okay, so given that the two triangles were similar, we know that the lengths of the corresponding sides are proportional, and that's how we found x and y. We set up these two proportions. Okay, let's move on to the last section. So this is on square roots and the Pythagorean theorem. Pythagorean theorem. Okay, so first let's talk a little bit about square roots. So first of all, a perfect square is a number that is the square of a whole number. So, for example, right, if I take actually we can do all the whole numbers, right? If I do 1 times 1, 1 is a perfect square. 2 times 2 is 4, right? 4 is a perfect square. 3 times 3 is 9, 9 is a perfect square, etc. Okay, so like 25 is a perfect square because it's 5 times 5. All right, so now what's called the principal square root. So the principal square root of a number let me write that neater here. A number n written like this. So this is the square root symbol. So that represents square root of n. Is the positive number whose square is n. So is the positive number whose square is n. So, for example, and I'll just stick with perfect squares to start. So let's say I want to find the square root of 64. Okay, so the rule says it's the positive number whose square gives you 64. Well, 64 is a perfect square, right? So what times what gives you 64? Well, that's 8. So the square root of 64 is simply equal to 8. Okay, so really that's all we're doing with square root. So if I do square root of 16, well, what number times itself, right? What positive number times itself will give you 16? Well, that's 4. So the square root of 16 is equal to 4. Square root of 121, what number times itself gives you 121? Well, that's 11. Square root of, do a few more of these, say 36. Well, that's got to be 6, right? Because 6 times 6 gives me 36. Square root of 1 is simply 1, right? Because 1 times 1 gives you 1. Square root of 9 is 3, because 3 times 3 is 9. Square root of, can you guess 225? And I'll give you a hint, it's a perfect square. So what times itself equals 225? And it turns out it's 15. Okay. Now, what if it's not a perfect square, right? What if you're taking the square root of a number that's not a perfect square? What if you want to find the square root of 10? Well, 10 is not a perfect square, right? There's nothing times itself that equals 10. We know it's going to be, we know that 3 times 3 is 9, and 4 times 4 is 16. So we know the square root of 10 is going to be in between 3 and 4. So how do you figure this out? Here's where you use a calculator. So pull out a calculator, make sure it can do square roots. And in this case, we're just going to estimate it. So I'll plug it into my calculator, square root of 10, and I'm getting around 3.16. So I'll say this is approximately 3.16. So if it's not a perfect square, you're just going to have to use your calculator. What if we did square root of, let's say, 102? Okay. We know square root of 100 is 10, right? Because 10 times 10 is 100. So this is going to be a little bit bigger than 10. So you plug it into your calculator, square root of 102, and I'm getting around 10.099. Let's say if I wanted to round it to, let's say I wanted to round it to the nearest hundredth, right? So that would be this spot right here, the 9. I look to the right, it's 5 or greater, so that's got to go up to 10, but I can't put a 10 there, so I put a 0 there and a 1 in the tenths place. So if I want to round it to the nearest hundredth, this would be 10.10. If I want to round to the nearest tenth, it'd just be 10.1. Okay? So for numbers that are not perfect squares, you're just going to have to use a calculator. Okay, so what if let me give you another problem here. What if I said square root of 7 lies between what two consecutive whole numbers? Now again, of course, you could estimate this using a calculator, but if you think about it, right, we know that the square root of 4, since 4 is a perfect square, is equal to 2, and the square root of 9 is equal to 3. So since 7, right, is greater than 4 and less than 9, then the square root of 7 must be between 2 and 3. Right? So we find basically the perfect square below 7 and the perfect square above 7. So it's going to be 2.7, or sorry, 2 point something, right? So you would plug this into your calculator and you could estimate it, and we know it's going to be around 2 point something. But in this case, we just wanted to figure out what two whole numbers it was between. Okay, so that's it for square roots, although we will need them in this next topic. So next I want to talk about the Pythagorean theorem. So this theorem deals with a right triangle. So a right triangle is a triangle with a right angle, which is a 90-degree angle. So let me draw it out here. So this angle, usually you denote it by a little block there. This is a 90-degree angle. So this would be a right triangle. So usually what we do is we call one of these legs A. So this is like leg 1. This one, say B. This is like leg 2. And then the longest side, which is opposite, always opposite the right angle, the 90-degree angle, we call that C. And this has a name. It's called a hypotenuse. So hypotenuse. Okay, so what does the Pythagorean theorem say? It says for every right triangle, the sum of the squares of the lengths of the two legs so the sum of the squares of the lengths of the two legs equals the square of the length of the hypotenuse. So equals the square of the length of the hypotenuse. Okay, so that's the Pythagorean theorem in words. For every right triangle, the sum of the squares of the lengths of the two legs equals the square of the length of the hypotenuse. But we can write an equation that represents the same thing. We know the two legs, right, are labeled A and B, so length A and length B, and the hypotenuse is C. So translating that sentence into an equation, we can write this as A squared, right, that's length of leg 1 squared, plus the length of leg 2 squared, B squared, has to equal the length of the hypotenuse squared. So really that's the way you should remember the Pythagorean theorem. Label the two legs A and B, label the hypotenuse C, and then A squared plus B squared equals C squared. That's the way you should remember it. Okay, so let's look at a couple of problems here. Let's say I want to find the missing length. Here's my right triangle. Let's say this is 6 feet. I'll call that side leg A. Let's say B is 8 feet. And then C is the length I want to find. Okay. Well, since it's a right triangle, I know that the Pythagorean theorem holds. So I can say that A squared plus B squared is equal to C squared. So A is 6, so I square it, plus B is 8. I need to square it, and that's got to equal C squared. So 6 squared is simply 36. 8 squared is 64. That's got to equal C squared. And then 36 plus 64 is 100, is equal to C squared. So the question is, how do I solve for C here? Let me write it, the variable on the left-hand side. Well, to undo the square, you take the square root. Okay, so let me write that here. To undo a square, we take the square root. So what I want to do is I want to take the square root of C squared because I want to get C out of it. That'll give me back C, right? It undoes the square. But whatever I do to one side, I have to do to the other side. Okay? Actually, this is a little more complicated. It turns out that when you do this, you have to assume that it could be either positive or negative, the answer. But for now, we're just going to take the positive square root. So now the answer is going to be the square root of 100. Well, we know how to do that, right? 100 is a perfect square. So what times what gives us 100? That's 10. So the length of side C, the hypotenuse, must be 10, and it has units of feet, right? So this has to equal 10 feet. So that's 10 feet. Let's do another one. Let's say this is my triangle. So it's a right triangle. Let's say this leg is 5 meters. This leg is 13 meters, which is actually, that's the hypotenuse, right? It's 13 meters. And then the other leg is unknown, let's say B. So again, it's a right triangle. I know that the Pythagorean theorem is going to hold. I know the lengths of 2 of the sides. I can find the length of the third side, right? I can find the length of that last leg there. So a squared plus b squared must equal c squared. So I have 5 squared plus b is still unknown. That's going to equal c squared. And then if I work this out, this is 25 plus b squared is equal to 169. And then how do I get b squared by itself? Well, I have to subtract 25, right? But whatever I do one side, I have to do the other side. So b squared here is going to be 144. And then how do I get b? Well, I need to undo the square by taking the square root, right? If I take the square root, but whatever I do to one side, I have to do the other side. And again, we're just going to assume it's the positive square root. So b here is equal to, well, what's the square root of 144? Again, this is nice, right? 144 is a perfect square, so it's going to be 12, right? Because 12 times 12 gives us 144. So this will be 12, and it has units of meters. So the length of that last leg was actually 12 meters. So this was equal to 12 meters. Okay. If your answer is not a perfect square, just plug it into your calculator to estimate it. Okay, let's look at this example here. It says, a contractor leans a 20-foot ladder against the side of a building. The base of the ladder is 12 feet from the base of the building. How high up the building does the ladder reach? Okay, so we definitely want to draw a picture, right, to see what's going on. Let's say this is the ground, right? Here's the building. Here's the ladder. And we're told that the base of the ladder is 12 feet, right, from the base of the building, so 12 feet. It's a 20-foot ladder, so that means the length of this ladder, this length is 20 feet. And we want to figure out how high up the building it goes. So I'll just call this h. The unknown is h. So we want to figure out h. Well, notice here, assuming the building is going straight up, right, which it should be, this is a right triangle, right? That's a right angle there. So I could extract out this right triangle. I'll draw it in red. And since we know the length of the hypotenuse and we know the length of one of the legs, we can find the length of the other leg, the h, right, by using Pythagorean theorem. So we know that h squared plus 12 squared must equal 20 squared, right? The length of leg 1 squared plus the length of leg 2 squared has to equal the length of the hypotenuse squared. Now I can solve for h. So h squared plus, this is what, 144, is equal to 20 squared is 400. And then I can subtract 144 from both sides. So I get h squared is equal to, this is going to be 256 when you subtract. And finally, how do I get h by itself? Well, I need to take the square root of both sides. So square root of h squared is h, that's what I want. Square root of 256, you could plug that into your calculator. Actually, in this case, it also happens to be a perfect square. This is equal to 16. 16 times 16 is 256, right? But again, if you don't know that, just plug it into your calculator and you should find it's equal to 16. And it has units of feet. So it looks like the building reaches up 16 feet, right? So this distance right here would be 16 feet up the building from here to here. All right, great. Let's do a couple more problems. And actually, we'll look at a couple of myopia math homework problems now. Okay, so in this homework example, it says find the length of the leg x. It's a right triangle, right? So again, we can just immediately use Pythagorean theorem. So I know that x squared plus 8 squared is equal to the hypotenuse, which is 12 squared. So x squared plus, this is what, 64, is equal to 144. So to get x squared by itself, I need to subtract 64. So x squared equals, and then 144 minus 64, this is what, 0. And then I need to borrow, 14 minus 6 is going to be 8, right? So this is 80. And then I want to take the square root of both sides to get x. So x is equal to, well, the square root of 80 is not a perfect square, right? So I have to estimate this on my calculator. So if I do that, let's see, square root of 80, I'm getting 8 point, well, they want us to round to the nearest hundredth, right? So I'm getting 8.94. I have to go at least to the thousandths place, right? 4. So if I round to the nearest hundredths, then this is just going to be 8.94, right? Because if I look to the right, that is a less than 5, so that stays a 4. So 8.94, and then there's no units here, so just 8.94. Okay, here they just want us to simplify these square roots. Well, these are nice, right? Because these are perfect squares. What's the square root of 9? What times itself gives us 9? Well, that's 3, right? So this is just 3. And then what is the square root of 49? Well, 49 is also a perfect square, right? Because 7 times 7 is 49, so this is just 7. So that was very straightforward. Okay, and then let's look at one more problem. So in this problem, we have this picture drawn, right? We have a ladder again, which is 3 feet from the base of the house. And then the roof line is 6 feet above the ground. And we want to know the minimum length of the ladder. So they say height, but they really mean the length of the ladder to reach the roof. So if we draw this out, right? Let me draw this as, first of all, it's a right triangle. And we know that this length is 3 feet. This length is 6 feet. And we're looking for the minimum length. So basically from here to here, right? Because it has to at least touch the roof here. So basically we're looking for this hypotenuse, which I'll just call C again. So let me call this leg A, this leg B, and we're looking for C. So again, since it's a right triangle, we know 2 of the lengths, right? We know 2 of the sides, in this case the 2 legs. We can find the third side, which is the hypotenuse. We can use Pythagorean theorem. So a squared plus b squared must equal c squared. So I have 3 squared plus 6 squared is equal to c squared. So this is 9, right? Plus 36 is equal to c squared. Well, 9 plus 36 is what, 45? So I have c squared is equal to 45. I want to solve for c, so I need to take the square root of both sides. So that gives me c, square root of c, square root of c. And then what's the square root of 45? Well, it's not a perfect square. We know it's going to be between 6, because 6 times 6 is 36, and 7 times 7 is 49. So it's going to be between 6 and 7. We can estimate it by plugging into our calculator. So I want the square root of 45. Let's see, I plugged it in. I'm going to get 6 point, what do they want us to round it to? Let me see. It doesn't say for rounding. Okay, let's round it to like the nearest hundredth of a foot. So we're getting c equals 6.708. So if I round, and this is feet, if I round it to the nearest hundredth, it's a 0 here. I look to the right, it's an 8, right? 5 or greater, so that's got to go up to a 1. So I guess this would be 6.71 feet. That would be the length of the ladder, the minimum length of the ladder, so that it reaches the roof. So this has to be at least 6.71 feet in order for it to reach the roof there. Okay, great. That's all I wanted to cover with Pythagorean theorem. Thanks.